to determine whether a function is continuous at a given point, we're going to check 3 things, okay? First, see if the function is defined at that given point. See if f of a exists, okay? Is f defined at x equals a? Find that function value first and write that down, because we're going to have to compare that function value to something else, okay? Number 2, does limit of this f of x as x approaches a exist? So how do we do that? How do we find that the general limit exists? Well, find the left-hand limit and the right-hand limit and see if they are the same, okay? If the left-hand limit and the right-hand limit are the same, then we get to say that the general limit exists. You write that down, okay? And third, you have to compare the function value that you found on part A and the limit value that you found on part B and see if they're the same, okay? If f of a is equal to the general limit of f of x as x approaches a is the same if the function value at x equals a and the limit at x equals a are the same, then f is continuous, at x equals a. So that's what we are doing when we have to answer a question about continuity, okay? Find the function value, find the limit, compare them. If they are the same, conclude that yes, they are continuous. In the next couple videos, you will see different examples. Sometimes functions are continuous, sometimes they're not. Watch the next couple videos on different examples. Some of them I attach graphs, some of them I don't. But I will ask you to answer one continuity problem on your first exam where I'm not going to give you a graph. So you will need to know how to do this algebraically, okay? So let's look at the first example on this paper, on this page. Let me read this though. What is this? A function is continuous over an open interval I if it is continuous at each point A and I. If f is not continuous at x equals a, we say f is discontinuous or has discontinuity at x equals a. Okay, so let's look at this first example where I attached a graph from a Desmos graphing calculator, and it is asking, is the function f of x equals x squared minus 3x plus 3 continuous at x equals 4? Well, in pre-calculus, I remember talking about, we said, well, the function is continuous if we can sketch the graph without lifting our pencil. And yeah, we can do that at x equals 4. This graph, this is a parabola and it is continuous everywhere and at x equals 4. But how do we show that using this 3-part definition of continuity? So step number 1, do this with me, is f defined at x equals 4? In other words, can you find f of 4? Can you plug in 4 into this function and find what it is? Yeah, we can, right? Quadratic is defined everywhere. Domain of quadratic function is all real numbers. So we can plug in 4 into this function. So let's plug it in. 4 squared minus 3 times 4 plus 3. That's 16 minus 12 plus 3. And that comes out to be what? 7, right? So yes, f of 4 is 7, and I'm going to box this answer because I'm going to compare this to the second part, okay? Now the second part is the limit. The second question that we are asking is, does limit as x approaches 4 of our function f of x exist? And, well, I will do this graphically for this problem. Yes, it does, right? From the left and from the right, they're both going to the same number 7. Actually, we can actually find it. Let's find this by direct substitution. What is this limit? Limit as x approaches 4 of x squared minus 3x plus 3. We do this by direct substitution, don't we? And the work is going to be exactly the same as what we did to find that function value. And that does come out to be 7. So yes, the limit as x approaches 4 of f of x is equal to 7. So we box this because we are comparing these two purple boxes. When they are the same, we get to conclude, yes, the function is continuous. So here's my conclusion, okay, number 3. Yes, f is continuous at x equals 4 because, and you say that f of 4 is equal to limit of f of x as x approaches 4. Ooh, you don't want to write the 4 inside. You write down f of x here. So practice writing this limit notation, okay? Practice writing, okay? Because on your first exam, the continuity problem, I will ask you to determine continuity using this 3-step definition, okay?